All right. Happy Tuesday, everyone. Winter seems to be settling in throughout most of the continental United States now, and when that happens, well, this is the time of year you start to notice those annoying little drafts. It might not be anything major, but it's enough to where you wish the builder of your home would have taken the time to button it up just a little bit tighter. We've got some good news. We don't have to keep making those same mistakes anymore. And why is that? Well, we've got Charlie Hack with us today to talk about 5 priority air sealing locations around a new home. As the home building industry starts to see more and more jurisdictions transition to more stringent residential energy code requirements like the 2012 or the 2015 IECC, which require blower door testing, some have reported difficulty meeting new air tightness requirements such as the 3 ACH 50 air level. Proper air sealing is critical to meeting these new air tightness targets, and there are strategic locations that should be a focus for builders. Research findings have quantified significant air leakage from 5 specific locations and estimated their potential contribution to ACH 50 reductions. Charlie's going to identify these 5 locations and share how builders can target these locations to boost air tightness levels. Now, some of you might be saying, who's Charlie Hack? Well, he is Director of Technical Services for the North American Insulation Manufacturers Association, or NAMA. In that role, he supports the development and adoption of building codes and standards, the creation of training programs, and advocacy efforts with green certification programs. Prior to joining NAMA, Charlie was a manager at the consulting firm ICF, where he directed a team of engineers and energy analysts performing energy policy analysis for the US EPA's Energy Star Certified Homes Program and International Energy Efficiency Studies. Charlie graduated from Pennsylvania State University with both a Bachelor and Master's of Architectural Engineering and is a lead accredited professional. While at Penn State, Charlie interned with ASHRAE in their Washington, D.C. office, as well as several architectural and engineering design firms. Before we get going, I wanted to let you know today's webinar is sponsored by the Insulation Institute. They leverage the collective insulation expertise of their organization and their members to empower homeowners and professionals to make informed insulation choices. Their mission is to enable a more comfortable, energy efficient, and sustainable future through insulation. And they are constantly working with building professionals, homeowners, government agencies, and public interest, energy, and environmental groups to realize that vision. And finally, during the course of today's presentation, you are more than welcome to submit questions for our guest. Simply use the questions box on the right side of your screen. I'll review those questions and I'll pose them to Charlie during the Q&A time set aside after his presentation. Charlie, welcome to the program.
Great, thank you, Mike. And thanks to everyone for joining us today. As he mentioned, we'll be going over the top 5 priority air sealing locations in new homes. And as Mike noted, feel free to enter questions as we go along, and we'll get to them at the end of the webinar. All right, let's get started. So as Mike mentioned, NAMA represents the manufacturers of fiberglass and mineral wool insulation products. And just wanted to give you a little bit of overview here of who we are. We provide homeowners professionals with information on these products through the Insulation Institute. And our website includes blogs, technical specifications, and other articles that you can access there. All right, so let's get started on what we'll be discussing today. So first, I'll go over why this information is needed and what's driving people to look at more locations to air seal. Second, I'll talk about the studies that were conducted and used to create this presentation. And then the third item is where I'll spend the bulk of my time as I walk through the 5 priority air sealing locations. And then lastly, I've included a slide with some helpful links and resources on this topic. Great, so let's start with the first part on the need for this information. So Mike talked about it a little bit, but what's driving the need to get down to these lower infiltration levels? So starting with the 2012 IECC, whole house infiltration levels were tightened up to 5 ACH 50 in climate zones 1 and 2, and 3 ACH 50 in climate zones 3 through 8. So this is a step up from the 2009 IECC, which had a target of 7 ACH 50, and even had an option that was leveraged in many states that didn't require blower door testing measurement, but could be visually inspected. So people are both having to test now and have more stringent levels to meet. However, even in states that don't have these new targets, there is a demand for high-performance, energy-efficient homes that's driving the need to improve these air leakage rates. So whether it's simply looking to improve the energy rating index or ERI score of the home, or to meet Energy Star, the Department of Energy's Zero Energy Ready Home, or Passive House, getting better infiltration numbers can help you get to where you want to go. Okay, so now that we've covered the need for reducing infiltration rates, let's cover the studies that we leveraged for determining the 5 priority air sealing locations. So the Insulation Institute released a guide that outlines the top 5 air sealing locations in new homes. It's available on the Insulation Institute website, and it covers the same topics that I'll be discussing during the webinar today. And the source of the information within that guide are a couple of different studies. The selection of these top 5 locations are based on a set of laboratory studies that looked into the leakage of key air sealing locations. So these actually outline more than what we're going to talk about today. There are actually over 14 locations described in these documents, and we just pulled out the top 5 for you all today, and for that guide that I mentioned. All right, so let's get to it. Let's talk about each of the top 5 locations for air sealing, the main part of our webinar today. So the first location is sealing the top plate to drywall. So this is for homes with vented attics that are insulated at the attic floor, the ceiling from the room below. And this can include over 300 feet of cracks to seal for a typical single-family home. So this location is very important to air seal, as it's a high point in the home, which can contribute to the stack effect, multiplying the effect of these cracks compared to other cracks in walls or elsewhere. So let me just show you what I'm talking about, the different image. On the right here, this is a view from up in the attic, and you can see all the areas where cracks could occur in a typical ceiling. So the brown are the top plates for the walls that are framed out below, and the white is the gypboard that's attached to the ceiling. So there's small gaps between the two of these all throughout that ceiling. Now there are 2 ways to tackle this. You can seal the cracks from the attic space from above, or you can add a seal on the inside face of the top plate before you put that ceiling drywall up, or ceiling and wall drywall up, and we'll cover both of these in the next couple of slides here. So let's talk about sealing these cracks from the attic above. So you can see the crack on either side of the top plate here. Well, infiltration can occur. The top plate is that wood member going straight from the bottom to the top of this image. So that's running down the center of the picture. So one solution is to spot apply spray foam along the length of the crack to seal it. So one of the disadvantages of this approach is timing of trades for insulating the attic. So as you can see, these photos are actually taken in an existing home. And as you can see, it would be pretty labor intensive to move the insulation out of the way to do proper air sealing in the attic space. You would want to do this ideally prior to installing the attic insulation. So there could be timing considerations. So similar to the last set of photos, we have a top plate in the attic space that isn't air sealed, and there's a gap between the drywall and the top plate. Another solution is to use caulk products to seal the smaller gaps at these locations from the attic above. And another location in the attic above is where 2 walls come together. So it's not just the drywall to the top plate. Oftentimes where walls, the top plates come together, there could be gaps, and a spot application of spray foam or caulk at this location could be a solution. Now the other method is to add a gasket or a seal before the drywall goes up. So I've highlighted here in red here where a seal or gasket could go along the inside face of the top plates. So here's a picture of an actual wall in a new home, and you can apply caulk at any time. I just highlighted a line where it could go before the drywall crew comes out to put up the wall and ceiling drywall. So it's also much easier than working in the attic after the drywall has been installed. But what's also good about it is that if you somehow miss this, if the drywall gets put up before the gasket's put in place, you always could still go up into the attic and seal from above. And it won't slow down your drywall sub if they happen to show up early, or in the gasket or the caulk that you decided to use that weren't put up yet. So there's also a gasket product like this that you could use prior to the drywall going up. This example, they used a sill sealer product that they split to fit the height of the top plate. Now, this isn't explicitly called out as a top plate to drywall item, but I wanted to bring it up anyway because it's something that connects the top plates together. Now, there are often framed corners or shafts where there isn't drywall at the top of the space, there's no ceiling. And you'll want to include blocking at these locations and seal the edges to the top plates to reduce leakage. There's often these odd little triangles or shafts that you'll want to block off and seal. Okay, so to summarize, the number one location here, there's likely over 300 feet of cracks that would need to be sealed at this location. Sealing at this location is highly effective as it reduces the stack effect, which is a multiplier for infiltration in the home. And again, there are two options for air sealing at this location. You can do it from the attic above after the drywall has been installed, and ideally before the insulation has been installed in the attic. Or you can add a gasket or caulk on that top plate, inside face of that top plate, before the drywall goes up. The second of these two is what we've seen most people go with for new builds because you have access prior to that drywall going up. So let's talk about what kind of ACH 50 impact this has on the home. So air sealing at this location can reduce infiltration by up to 1.6 ACH 50 in a typical single-family home. Now, of course, this will vary based upon the size and configuration of the particular home that you might be working on. But out of all the items I'll discuss today, it's the largest source of air leakage that you can address. Great, so that's number one. Let's move on to number 2 of 5, recessed lighting. Now, this is only applicable to homes that have vented attics where the lights are installed between the living space and that unvented attic. In a typical home, there could be 10 or more of these lights, depending on the configuration of the home. So the first thing to look for is whether the can light is ICAT rated, and that means insulation contact airtight. And typically there are labels, as I've outlined here, pointed to here, that will say ICAT rated. You can look at it when specifying the can light or when you have them in the field there. And the area that you want to be sure to seal is the bottom of the can area to the ceiling. So you can see on the image on the right, there's a circle there. That's the part that you want to seal to the drywall below. Okay, so here's an example where a recessed light hasn't been sealed. And you can happen to see it because the trim is loose. So the trim isn't going to do a very good job at air sealing itself. You can just happen to see, since the trim is knocked down a bit, that this area hasn't been sealed. So one solution is from the inside, after the drywall has been put up, you can caulk and seal the bottom of the light enclosure to the drywall. Now you might think this solution from above might work, similar to what I talked about for the top plate, sealing around the recessed light fixture. Now, fixtures are typically rated so that the can enclosure around the light is what's airtight. And sealing here, as shown in this picture, wouldn't solve that as air leakage could occur through other parts of the fixture, where the wires come out, for example, or other locations that just might not be air sealed. So that's why it's important to seal the bottom of the can to the finished drywall on the interior. Okay, so to recap this location, There can be up to 10 lights in a home that would need to be air sealed. And just like sealing the attic top plate, this is highly effective because it reduces the stack effect, particularly when you have the light bulbs that are in these recessed fixtures. They're heat sources, so it can induce small drafts and leakages. And in terms of the effect on reducing the infiltration rate in the home, each light like this has the potential to reduce the infiltration by up to 0.2 ACH50 per light. So that can add up depending on how many recessed can lights you have in the home. All right, so that's the end of location number 2 out of 5. Let's talk about number 3 of 5. The duct boot to the finished surface. So this applies to homes with ducts in either unconditioned attics or in unconditioned basements and crawl spaces, or in both locations. So these duct boots are typically 10 inches by 6 inches each, and there can be 8 or more of them in a home. So the first area that I'll discuss is duct boots that are located in the attic and coming through the ceiling. So you can either seal them from above using a continuous bead of caulk, as shown on the left, or you can do it from below, and you can seal the boot to the drywall with caulk or mastic. Fiberglass meshes or aluminum tapes are also sometimes used if the gap between the drywall and the duct boot is large and caulk can't fill it easily. So here's an example of a return duct in a ceiling that hasn't been sealed. And as shown here on the right, you'll want to seal the connections to ensure that the leakage isn't occurring between the living space and the unconditioned attic above, especially at these locations where air is flowing into or out of these registers. Often can be pulled into the attic space. Now that we talked about ceilings, let's talk about floors. Here's an example of a duct boot that was not sealed to the floor below. You can see in the edge there, you can see the subfloor off to the right, and there's a gap there. And you'll want to seal the duct boot to the floor using mastic or caulk, as shown here. So this is before the finished floor is installed. It was sealed to the subfloor with mastic in this case, it looks like. So this will ensure that there isn't any air leakage between the living space and the unconditioned crawl space or basement below this duct boot. All right, so to summarize, sealing these locations is important as they're in a low location of the home or a high location within the attic. So again, it can contribute to the stack effect. That's why it's one of the top 5 locations. So in a typical home, there could be 8 or more of these boots that would need to be sealed. And in terms of air leakage, they can contribute up to about 0.2 ACH50 per duct boot. And that adds up as you have, like I said, you can have up to 8 of them or more in a home. Each one of those can contribute significantly. All right, moving on to location number 4, the band joist. It's also known as a rim joist. It's where the foundation meets the floor structure, and it goes around the perimeter of the home. So, as noted here, it's applicable to homes with and without unconditioned basements, as it's a leakage path for either type of home. And it can include up to 200 feet of cracks that would need to be sealed. So let's jump into what this area looks like and what we can do about it. Okay, so you can see here, we're in a basement of a home, looking up at the floor joists and the ceiling above. And the light you're seeing is actually shining from outside, a crack from outside the home. A clear gap where air can come through and flow into the home. And on the right, we're looking at a picture of a similar such bay where blocking has been included and it's been sealed with caulk, no visible gaps there either. So that's ideally what you'd do in each of these bays on your band joist. Now here we have the blocking in place, but it's not sealed, and on the left. And then on the right, it's been sealed, and then they've included insulation in front of the ceiling as well. Here's another example where you can see gaps next to each of the floor joists. And there's certainly paths for air leakage. And another method is to use a spray foam at this location, but it's likely costly compared to just sealing it with a caulk or even just can foam and installing mineral fiber insulation. Now, sealing from the inside isn't the only method to meet this. You can use products like tall wall sheathing to cover the band joist from the outside as well, so that there's a continuous air barrier from the outside. So tall wall sheathing is extra long sheathing that covers the band joist, and it can block the airflow from the outside. So to recap, the band joist location up to 200 feet could be sealed depending on the configuration of your home. And it can be sealed from either from the interior or the exterior, as it includes quite a few cracks that need to be sealed up from the inside. And the effect on infiltration is up to 0.4 ACH50. Again, it can be more or slightly less depending on the size and configuration of the home. All right, so that's 4 of 5. Let's talk about the 5th and final location that I'll be covering today. So that's leakage between an attached garage and the home, the conditioned space within the home. So clearly this is only applicable for homes that have attached garages. And as you can see from the floor plan that I've included here, any wall that separates the garage from the home is what we're talking about. So in addition to sealing the walls with drywall and providing gaskets and weather stripping for doors, the most overlooked area is where the floor structure connects the garage and the living space. So these details aren't just important for reducing infiltration into the home to save energy. It's also reducing possible contaminants and pollutants from entering the house from the garage, as people might turn on their cars in there or store different chemicals in their garage. So here I've included a picture of a garage wall, garage house common wall. So the wall cavities and the studs are below, and the area between the floor joists are above here. So in this picture, they're properly blocked off and insulated, just like the rest of the wall below. So what's different about this location is that it doesn't often get drywalled or sealed up there between those joists. And it can connect the ceiling of the living space with the garage. So here's an image of the same space without blocking. You can imagine that they've just left those gaps open, and air can flow freely into the ceiling above the living space from the garage and vice versa. So as a solution, you can cut blocking material and put it in there and seal around it. So it can be foam board, OSB, or another rigid material that's cut to fit. And just be sure to seal around the edges, as you can see in this last image here. So let's look at some other examples together. So here we have a picture of that exact same situation where the walls of the garage are clearly drywalled and ready to be sealed with drywall mud, but the ceiling above connects right to the living space on the other side of the wall. So the solution here would be to include blocking at those locations to keep the conditioned living space separate from the garage. And here you see a picture here of where it's been blocked out. Now, this issue doesn't occur just at the ceiling. In many homes that have a basement, the garage floor is a slab that's poured separate from the rest of the home, and it's a step or two down from the living space. So this often creates a 12 or even up to 18-inch area where air from the garage would be able to flow into that floor system between the main level and the basement. So you can see here where all the piping and wiring is located. That's actually the floor space or the ceiling space of the basement below. And it would be part of the conditioned space of the home, or it could be. So here's an example where it's been designed to include air sealing and blocking at that location to reduce airflow between the living space and the garage. All right, some more examples for you here. Here's an example where someone stepped up to try to address this issue, but failed to tailor their solution for the I-joist. They just cut rectangles out, but they didn't key it so that it would fit next to the I-joist here. Ideally, you'd cut a piece of blocking to fit, and you'd air seal around the edges so you get that full cover. Okay, so to recap what we just discussed on location number 5, the garage house common wall, there can be up to 6 or more bays in a typical home that would need to be blocked off and sealed. Again, it varies based upon the floor plan and how much wall area you have between the garage and the house. And in terms of the effect on reducing the ACH 50, approximately 0.2 ACH 50. Again, it varies home to home, but that's what the study concluded. So that's it. We've made it through all 5 locations. Let's take a look at and through and add up the impact from each item that we discussed. So we have up to 1.6 or more from sealing the attic top plate to the drywall. Recessed lighting comes in at around 0.2 ACH 50 per light. And remember, these are just the lights between conditioned and unconditioned space. If you had a light between a first and a second floor that are both conditioned, it wouldn't have that impact. And then we have duct boots. They come in at approximately 0.2 ACH 50 or more per boot. Same goes for these. You're only getting this benefit if it's between a conditioned space and an unconditioned space. So if it's above an unconditioned basement or crawl space, or it's coming down from an unconditioned attic. And then we have band joists that come in at 0.4 ACH 50 or more, depending on the size and configuration of the home. And lastly, that garage house common wall comes in at 0.2 ACH 50. And again, that's highly dependent on how much wall area the garage shares with the rest of the home. Now, I mentioned at the beginning of our presentation that meeting these more stringent air sealing targets are often to meet code requirements, but they can also be used to lower the ResNet energy rating index, ResNet HERT index. So this varies by home size and configuration, along with the weather location of the home, but I put together a small chart here to show you how reducing infiltration pans out in terms of reducing the energy rating index for a typical single-family home by climate zone. So the lower climate zones, like 1, 2, and 3, they're the warmer climates in the United States, and the colder ones are the higher numbers, 5, 6, and 7. So you can see in the warmer climates, it does have less of an impact, and that's because throughout the entire year, the temperature between the inside of the home and the outside of the home are much closer to one another in mild climates. You can imagine if it's 90 degrees outside, I have my thermostat set to 75. That's only a difference of 15 degrees or so. Although it's still important to air seal in these climate zones to reduce infiltration, you'll definitely want to have undesirable air not make its way into the home if it's coming through a crawl space or through a garage that might have contaminants in it. But you'll see that the points jump considerably as you get into the colder climates, the higher number climates. And that's because throughout the course of the year, the temperature outside is drastically different compared to what you have the thermostat set to inside. Even if you have it set to 70 degrees, say, during the winter, in a lot of these colder climates, it's 20 or 30 degrees outside for during the winter time, and that's a much larger difference in temperature than in the warmer climates. So by air sealing, you get much more of an energy benefit. Okay, we've made it. We're in the final section where I'll share some links and resources with you. So I've included a link to our website where you can find that air sealing guide that I talked about earlier. That's the summary of what we talked about in the presentation today. I've also included a link to the Energy Star program requirements webpage. They have a checklist, even if you're not looking for Energy Star certification. The Raider field checklist, it has really good guidance on additional areas to air seal, and they also talk about a little bit more as they have guides on how to address them. And lastly, I wanted to make sure everyone that joined today, anyone wanted to review the information that was the source for the ACH 50 values that I discussed. would have access to the reports that were used and the studies that were used to determine these top 5 air sealing locations. Great, so thanks for attending the webinar today. Include my contact information here, and if you have any questions, you can always email me too, but I think we can, as Mike mentioned, I think if anyone's written in the questions pane throughout the presentation, we can move to that section now.
That's right, Charlie, we are. We're going to move on to the questions. Again, if you have questions, use that questions box in the control panel. We're going to get right to it. So the first question comes in from Michael, and here is his question. He says that air sealing between the green board and the foundation is code mandated across the U.S. Why is this the only gasket interface mandated to block air intrusion? Wall to face frame blocks 80% of the air intrusion. And that's something that's vetted by New York State and confirmed by Home Innovation Research Labs. So ultimately, his question is, why is this the only gasket interface that's mandated to block air intrusion?
Which location? The band joist you're talking about in particular?
Yeah, air sealing between the green board and foundation is what he's referring to it as.
Okay. Oftentimes, it's required to have a gasket as a capillary break too, so that they require that in a separate section. So that oftentimes people will just always use a gasket at that location, and they don't think to use it at other locations since it's not mandatory. They feel that caulk or other products are cheaper.
Gotcha. And air sealing is most cost effective during framing, right? I mean, we're not to have people do callbacks and that sort of thing. It just hikes up the price.
That's right.
Yeah. All right. I've got a question from Dave. He wants to know about the 60 or so outlet and ceiling electrical boxes that are in the perimeter of a house. And obviously that assumes a certain size of house. But he says there are boxes and seal kits that are specifically designed for this type of application too.
Yeah, so that's a great question. I didn't actually address it in this because that's very low. The wall cavity itself is very low on the list of air sealing measures that you can do, because the wall in particular does not have very many penetrations that go all the way through the wall cavity to the outside. So electrical boxes and things like that typically only pierce the interior drywall. Obviously, there might be some other holes that are drilled in the framing members to run the wiring, but as far as to the exterior wall, they're not making holes through that exterior air barrier in that house wrap, the wall sheathing in the house wrap. So the walls themselves are actually pretty well air sealed compared to these high and low locations and penetrations that are going all the way through the envelope. So if you were to open up one of those studies, it does talk about outlets and other things like that, and they're very, very low on the list because the air barriers are already taking care of that. So some of the other studies talk too about air sealing using spray foam products in wall cavities. Yes, that does have a good air sealing capability, but if you have a good house wrap that's taped, studies have shown that it's comparable to filling a cavity with spray foam or using other kits for outlets and things like that. So, yeah.
Okay. I had a question from Paul. Paul was wondering about the 0.2 ACH50. Was that per bay or is that total on the garage house common wall?
That's the total number for the garage house common wall. I'd have to look at the study for the amount of area that they used for that, because that'll vary based upon how much wall area you have between the house and the garage.
Gotcha. Okay. Wanted to make sure to remind people to send in their questions via the questions box if you have any. I had a couple actually, Charlie. You talked about sealants, okay. Do we have to be worried about harmful off-gassing that when you combine it with a tighter home could present some IAQ, indoor air quality IAQ issues?
Yeah, that's a good question too. With these new codes, in particular starting with the 2012, when these more stringent air sealing requirements came into play, the International Mechanical Code also included mandatory requirements for whole home mechanical ventilation as well. So when this era of air sealing was ushered in, requirements for whole home mechanical ventilation also that came into play. So that's designed to, obviously air sealing will save the energy, but then we also have ventilation that's designed so you have a controlled amount of air coming in, and ideally you would know that the source of that infiltration that's coming in is ideally wholly outdoor air rather than coming through some crawl space or coming in from your garage, et cetera. Yeah, because obviously homes that were leaky or got a lot of infiltration to either remove contaminants, or if contaminants came in through the infiltration itself, there's enough infiltration occurring that it removed itself soon thereafter. So yeah, mechanical ventilation requirements are an important component of increased air sealing in homes as well.
And that requirement kicks in when you get to 5 EHCH 50 or less, right?
I don't think it explicitly says 5, but that's generally that's right. Yeah.
Okay. Final call for questions from the audience. I have another one for you, Charlie. So if you're going with an unvented attic, okay, and we're talking new construction here, you're going with an unvented attic, does that change any of the items that you highlighted today at all, or are we still need to follow this checklist?
So some of these items wouldn't be applicable because you wouldn't have an attic space above, but other ones still would. Most of the stuff I talked about obviously had a vented attic above.
Yeah.
So things like top plate the drywall, that wouldn't be as big of a driver. But obviously the band joist, the garage, house interface, and any lights that you have in that unvented attic, you'd still want to have taken care of. Or if you have a conditioned basement or unconditioned basement below, if you have duct boots coming up through that, it would still be important. So that's a good point too. You could review the study as well. Like I said, there's 14 items in that. So there are a lot of more minor items that are listed there if you're still having trouble meeting your air sealing target, and you have an unvented attic as well.
Well, and even though some of the minor things that we didn't, cover in today's webinar, they all add up, right? So
that's right.
Not that they should necessarily be neglected just because they weren't featured in the top 5 today.
That's right.
Dave has a late question here. He wanted to mention that where a wire penetrates a top sill plate, you have to use fire stop caulking. And if you use painter's caulk, it's going to get nailed every time by the inspector.
That's a very good point. I believe there's also, in addition to caulk that is fire rated, I think there are some spray foam products that are fire rated too for use. I think sometimes there's flues or other things like that can get quite hot, that are penetrating into the attic space. You'd want to use the proper fire rated material there too.
Gotcha. All right, I don't see any other questions, Charlie. So I certainly want to thank you for joining us today. Any final words, Charlie?
No, just thanks everyone for joining, and check out our website, see if you can explore the other resources that we have there on insulation.
And also a reminder to our audience, this is being recorded, and it will be on the Green Builder Media YouTube channel, and there will be a follow-up email sent out to all webinar registrants afterwards that will have information about Charlie's slides in PDF format. So be sure to check that out. I know one of our attendees said he can't wait to share those with some of his contractors. So, all right. Thank you very much, audience, for attending, asking questions. Thank you, Insulation Institute, for their generous sponsorship of today's webinar. And with that, we conclude the Green Builder Media webinar series for 2018. I hope you enjoyed all the topics and guests that we featured throughout the year. And if there's a topic you'd like to learn more about, don't hesitate to contact Green Builder Media and let them know. In case we don't talk again before mid-February, I want to recommend the Green Building Media Sustainability Symposium at the University of Nevada, Las Vegas on Monday, February 18th. I'll be there, and I'm looking forward to hearing from people like General Wesley Clark, Ron Jones, Bill Walton, Jeff Bridges, and many others. If you're already planning to attend Design and Construction Week, then don't miss the premier green building event of the year. Now, if you're not going to be in Vegas, then hopefully we'll see you back here in 2019. I hope you find time to relax and enjoy the holiday season with family and friends. Stay safe, stay warm, and have a happy new year.